KTV!
Hi, welcome to Podcast School, the educational podcast that allows you to learn anywhere. Today we're going to take a look again at resistant materials, and this time we're going to look at metals. So, metals can fall into two basic types. Ferrous metals, and these contain iron, and non-ferrous metals, and these obviously do not contain iron. So those are the two types, ferrous and non-ferrous. But first, let's look at something called alloys. We'll read through the paragraph together and we'll use these words to put them into the spaces to gain an understanding of what an alloy actually is. Okay, so an alloy is what do you think? It's a blend of metals, or materials. By blending a heavier, strong metal with a light, weak metal, a lightweight, strong alloy can be formed. Alloys can be cast and shaped to produce flowing curves and fine detail while keeping their added strength. Alright, so really what we're saying there is different metals have many different properties. You can see a few metals in here, and well, first of all, they're different color, aren't they? But there's much more besides. But they have different properties, and and different advantages and disadvantages to using them. So by blending them together, we can almost get the best of a lot of worlds in one material. So that's alloys. Okay, now let's go back to ferrous metals, pure ferrous metals. We'll do the same again. We'll put in words into the blanks. So ferrous metals, just as I said, contain iron. The main element of ferrous alloys is iron, and its chemical symbol is Fe. Now, unfortunately, ferrous metals become, that's right, oxidized, and we can cover them in a protective coat such as paint or enamel. Enamel is just a type of a protective coating to help stop it, but if the protective coat is damaged, of course, the oxygen reaches the metal and rusting takes place. And you can see there's some rusting in action, and really what rust is indeed iron oxide. And it's that, and it's red, and it's that redness that we can see on rusted iron and rusted ferrous metals. Now, let's come to something called mild steel. It's one of the most common ferrous metals and the softest one. It is grey in colour, containing about only 0.3% carbon. So this is iron with carbon deliberately added. It is used in manufacturing screws, nuts and bolts, chair and stool legs and car bodies. It is inexpensive to produce. Okay, so by adding a little bit of carbon, we can change the properties of the iron drastically. And by doing that, we can make a much more malleable material, one that we can really work with. Only 0.3% carbon, and it is very inexpensive, and we see that all over the place. Lots of industrial components are made from mild steel. Now, if there's mild steel, there's also probably something else, and you've guessed it, it's high carbon steel, and that's exactly what it says. It's carbon with a lot of iron in it. High carbon steel contains around 1% carbon. As I said there, the extra carbon allows tool steel, and tool steel is just another name for high carbon steel because it's used so much in tools. So it allows the extra carbon allows tool steel to be hardened, so it's ideal for tools such as screwdrivers and hammers. So it makes the steel very, very hard, and in fact we could probably do a whole podcast just on the properties of steel and how we can change it by doing different things to it, by heating it in different ways and at different speeds and things, and we'll probably see another podcast on that in the future very, very soon. Now, stainless steel, and you'll have all have heard of stainless steel. It's it's the same again. It's a ferrous material, but this time it's very special because it has about 10.5% chromium. Now that means it does not rust or mark easily. It's commonly found in sinks, saucepans and cutlery, so the knives and forks that we use every day will be stainless steel. It's very hard, making it almost impossible to drill or file, and it is expensive. So those are the downsides to it. There we can see a little stainless steel teapot, I think, and the pinnacle of the New York's Chrysler building is made from stainless steel. Okay, so that would have been very expensive, as you can imagine. Now, we can come to something, or we'll come to something called cast iron. Cast iron is a type of steel, just as before, but it's got an extremely high carbon content, between 2 and 4%. Alright? The reason for that is, by adding the carbon, it lowers the melting point. And by lowering the melting point, obviously we do not need a furnace as hot to melt it and to shape it. And because of that, it was used extensively in days gone by, whenever we didn't have such high furnaces. So lots of old parts, motor parts, parts for all sorts of things really, were made from cast iron, because they were the cast iron had such a low melting point. As you can see there's an old wagon wheel made from cast iron, and also our gratings are still made from cast iron. Okay, now we'll come to something called tin plate. Now I'm rushing through these, but don't forget, you can always go back at any time. Tin plate is an example of a ferrous metal, and you come into contact with that on a daily basis, but you must realize that whenever we talk about tins and our food being in tins, it's not actually tin at all. It's just a tin. It's just tin plated. All right. If we were to scratch the tin off the can, it would just rust just like anything else. Okay. So tin plate, and don't get confused with tins actually being tins. They're not tins. They're not made of tin. It's tin plate. Now, non-ferrous metals, and as I said before, these are metals that do not contain any iron whatsoever. Now, this is quite small text. Hopefully you can see it. If you can't, or if can't see it so well, make sure you get the PDF, which will come along with this podcast. Okay, let's fill these out together. Non-ferrous metals do, not contain iron, and therefore do not go rusty. This makes them very useful for jobs where they may come into contact with, moisture. It also means that they do not need a protective coating. There are many items made of non-ferrous metals. They are usually bright and shiny if kept clean. If left, they go dull. Alright, so aluminium's a good example of that. The dull layer on the surface does not hurt the metal. In fact, it protects it. Many of the non-ferrous metals are very expensive, such as gold, silver and platinum. You are very unlikely to use these metals in the workshop. The most common non-ferrous metals are more expensive than most ferrous metals. So, as I said before, aluminium is a great example of that. It's very, very common non-ferrous metal, but it is still a little bit more expensive than the most popular ferrous metals, than stainless steel, for example. Okay, so that brings us nicely, and I've left oxidized in there just to throw you. Okay, now that brings us to aluminium. So it's a lightweight metal. It is soft and easily shaped, silver grey in color. I said in a previous podcast actually that it does conduct heat and electricity well, and it's used all over the place. Everywhere aluminium's being used in high performance car engines, and in the body of cars as well, bicycles, all sorts of places, you name it, aluminium is around us. Copper then. Copper is actually quite tough, and it's easily shaped, and it's pink brown in color. We've all seen these pipes around, okay, but they're uh, not used. Copper's not used so much in water pipes. It's all really plastic now. It's an excellent conductor of heat and electricity, and in fact, the wires that we use for conducting electricity, they're all made of copper just because it's such a good conductor. It's quite expensive though, and you know, but it's not as expensive as some of the other good electrical conductors. It must be said, it's a good compromise. Brass. This is an alloy. It is a mixture of copper and zinc. Okay, so at the start we talked about alloys and how we can make materials with great properties, with the benefit of maybe two different other pure elements. So this is a good example. Brass, a mixture of copper and zinc. It is heavy, quite hard, and gold in colour. It's similar to copper in many ways, but with greater strength. Okay, and we've seen that used all over the places, and here's an example where they're used in hinges. Okay, so that was a very rushed run through of metal properties. I would expect that you'd have to go through and just review that, and I'll leave you to do that. But until next time, I'll see you later. Bye bye.